Okay, so welcome on another presentation. Now we will be talking about Dasharo Open Source Firmware Validation. So the agenda for today, at first I'd like to introduce you once again, because it's maybe not that well known yet, project. So we'll talk again a little bit about what it does, why we are working on this, how it works, what is the current state, what kind of recent improvements we have made, and the future plans. So typical status presentation, we can say. So let's start with the introduction and why do we care. Its main purpose is to validate, to verify the results of our work, and our work is mostly some kind of firmware binary that we run on a hardware device, and it contains a given set of features, and the goal is to deliver those features according to some kind of specification. So basically, that is the main tool of this job, is to verify certain functionalities of the firmware we are developing. It's called open source firmware validation, but in essence, it can validate. It can be used for any firmware. We did actually have a use case where we validated some of the I think secure boot menus of certain other third-party BIOS vendor, closed source one. Right now, we are mostly focused though on the Dasharo with UEFI payload. And as a base framework, we are using the robot framework, which is like which uses Python underneath, and it's maybe a bit weird syntax we will see in a moment. So as I said, it's mostly for testing Dasharo firmware releases. Right now, when adding new features, we care about adding tests as well where possible. We are using it mostly for the regression testing. So whenever we are releasing a new release candidate, we are running this set of tests to ensure that we do not regress and that the newly introduced features work as expected. As Daniel said before, it's also we are extending usage of that to other tools we are developing, because we have the DTS. We have also some configuration utility that we can configure the binary Dasharo binaries with. So those are also tested using this framework. The typical setup looks as follows. We do have some hardware device. We need to figure out how to control the power on the given device. So it's either some relay or maybe some controlled power supply unit. In most cases, we rely on serial console for testing. So we parse the serial console output, and based on that, we make certain decisions in our test suite. And we use Cert2Net application, which basically allows us to use this serial console over network. A typical test case looks something like that. We power on the platform. We go through we go into some firmware menu to switch some option, and we check the result of set option in firmware, operating system, be it like our Dasharo toolsuite reference, or Ubuntu, which we commonly use for testing, or Windows 11, which many of our customers need to be that their hardware works correctly with Windows, as well as OS for some tests where it's required, especially for instance with the heads. So how one test could look like? So we need to press a key to enter setup. Then in our test case, we go through these menus. For instance, we go to the Dasharo system features. Then in the test case, we go to the security options. Then we go to the SMM protection, and either we enable that or disable that. And then we save and reset, go to the OS and check whether certain protection is as expected, or if it's disabled, if it's really disabled. In terms of code, that's roughly how an example test case can look like. So we start typically with some power on action, which is hardware specific, defined in like platform configs, and then we have certain keywords for entering certain menus and selecting options. So we enter the menus shown on the previous slides, then we select option to true or false, so set or clear this option, boot into operating system, and then execute some commands in the OS, and based on that we can judge whether certain feature works according to how we think it should work. So that was a brief introduction on what it is. Now the current state. So we tried, or we promised, or we planned for a release, but we haven't delivered like a targeted release with some declared feature set, we can say. It's like getting more and more complex. We are still failing to define the criteria that we would like to achieve. We are adding new platforms, new tests. Right now it's worked like more on a rolling release basis in the develop branch. And we were hesitant to merge it back to the main, but it really never happened. And it was a bit confusing to see that the default main with very little updates and outdated information. So we just, or maybe I just merged that from develop to main. And perhaps until we figure it out, we should use that as a base for development. In terms of statistics, we can definitely see increase in development. What may be a bit worrying, and what we are working on right now to reduce the number of open pull requests, because it's almost 30 right now. And it's getting more and more difficult to go back to these older ones. We definitely need to take care of that a bit more. So that was the main open source firmware validation repository. We have also another one which currently holds mostly the open source our CLI, which we use to control the platforms for like power on, power off, reset, whatever. In terms of tests, we have roughly around 500 of them right now. From different categories. Some are like specific to very specific cases like trench boot or UFI capsule tests or DTS, but many of them are generic and started with most of the releases. Maybe we can rework this slide to also show the increase with each quarter, with each presentation. But right now we just have a snapshot from today. What kind of recent improvements we have made? We're adding new tests each month, basically. So if we're introducing new features like CPU, PE cores configuration or hyper-threading configuration, so that was also added to the test suite. So we are introducing new tools like DCO, we also need to cover that with tests. DTS was mentioned by Daniel. We did some more work in TrangeBoot lately, so that's also covered here, that we boot Linux Zen with meta TrangeBoot images and just check some basic stuff here. We've been developing capsule updates, as was mentioned by Piotr, so we also have tests for that. New platforms, Odroid was mentioned. So if we have a new platform that we are working on, it needs to be set up in the lab, and it needs to be added to the test environment. We are working also on some new Protectly boards, which are not released yet, but you should expect those in a few months to be in the market. So in the last presentation, we said that was the plan, and we are able to deliver that. So good for us. So we managed to move the low-level operations from robot framework into common Python libraries. So we can now use the same set of libraries for both tests and CLI. We are using like developer use it, for instance, when they are working on firmware development. So we have the same code paths for controlling device under tests, be it from tests or just manually. DCU integration, that was also delivered. So that's an optional path of changing firmware settings, not via firmware menus, but via changing the SMM store region. It was useful in a few cases and allows us to execute a bit more tests on, for instance, laptops where there were difficulties with serial port accessibility. We've delivered keywords documentation, so that is live in GitHub pages right now. What can be improved is definitely the actual documentation within the keywords, but at least it's there, it's automatically deployed, so it's a good start. Next steps, right now we are working also on the CBIOS support, as Piotr said. So we have a pull request for that, and we would like to finalize that, somehow integrate that, which is a bit challenging because the existing design is most suited for the, as I said, for the UEFI way of changing stuff in the firmware, and we need to come up with some interface to abstract away some of the parts and to be able to reuse the common parts no matter what kind of firmware we use. And I think that our main focus should be now on repeatability and reliability of tests that we have right now than adding new tests or new features to basically reduce the number of iterations, because right now we typically need to run a few of them during each regression cycle. There are many kinds of problems, for instance, related to the power on activities. That device the power control is not as reliable as it should be. We need to identify other areas like that generate the most problems during regression cycles, and stress them and make sure those can work as expected and reliable. We do already have some CI tests, but those are only in QEMU. Maybe those are not enough, or apparently those are not enough. So we definitely need to work on hooking at least one or two additional hardware boards to the CI loop, so we can make sure that the keywords we have, or the at least selected scope of the test, can work reliably on certain type of boards. Okay, that's it in terms of slides. How we are on time?
Yeah, we have 4 minutes, and yeah, please feel free to take more if needed. I don't have anything at the end to announce, so.
No, that's so. I'm good in terms of slides. I can maybe answer some questions then, or showcase something. I don't know. Do you have some? Are there any more questions than we had before?
Yeah, I don't see any additional questions here. Let me check out the Dasharo developers VPOP. No, like I don't see any remaining questions.
Can I ask a question?
Oh, sure,
Yes.
Reach.
So the question is, what do you want to do with this from a community point of view? For example, let's say somebody wants to write a new test case. Can they use, do they need to stand up their own full infrastructure? Could they submit their test case against some of your hardware? Where should people contribute or could contribute?
We have QMO, so maybe we can briefly show how it works. We can definitely come up with even more test cases in this emulated environment, so no hardware is required actually to get started. We have like a script to run the QMU with our firmware, and we can, I guess, run some tests as well.
So basically, somebody could download, I don't know, a tarball, and then fire up QEMU on their
clone
local
repository and follow the README to run QEMU and run some tests.
And the tests will run against like.
So essentially, inside script there is downloading of some certain version of QEMU. Yeah?
Yes, the latest
like
release, I believe.
Yeah.
And it's like have a feature which takes too long to boot. That needs to be fixed, and it's one of the points that Piotr you asked about the time. But here we have the Dasharo QEMU version, and right now we can see that we are testing network boot feature. So we go to the networking options. We will enable the network boot. By default, it's disabled. And we will reboot and confirm that a new boot option has appeared, like the network boot option. And we can have, I guess, many more cases, not only the positive ones. We can have more stress tests or some fuzzing. I don't know.
Yeah, I guess like QEMU is also not because QEMU may be the thing when Dasharo will enter the land of confidential computing and firmware for confidential computing VMs, which is not here yet. My kind of idea was that people could contribute the test results and run the test results themselves. Of course, full infrastructure is kind of complex because someone will have to buy RTE or have some other controller which is integrated in the framework, and then it drives the flashing or power cycle or this kind of stuff. But there are some tests which could run over SSH. So Maciej, maybe from this angle you can say something. Or over serial.
Yes, over serial. There are some ideas how to make it a bit less pricey to get started with. So, for instance, you have the Odroid platform. You connect it to your PC via some cheap UART converter to gather serial to your PC. You can run the Cert2Net service that we use directly on your PC, and I guess we could hook up in a way that the test even like asks you power on the platform now to proceed, or change some, because assuming we don't have like a full power control, so the desk can like wait for your action to do some stuff which is not automated due to lack of hardware, for instance.
What about something like PyKVM?
What about
As an interface to, as a sort of semi-standardized, a popular thing that people might already have for other purposes, which they could then use for test automation?
We do use PyKVM for mostly remote access, for getting like video output for developers, or for emulating keyboard. The problem is maybe a challenge is that we rely on like parsing these firmware menus right now over serial, over text, using text. And if we want to like rely on video output only, that would also definitely enable some use cases like the laptops, which are problematic, but would require some kind of image processing, I guess.
Okay, I don't remember what Cubes uses OpenQA, right? And I think that has.
Yeah, they do something like that, like image comparison.
Right.
Yes.